Hello students, welcome back. We completed section 1. Now let's go to section 2 and study quadratic equations. Again, most of it will be reviews, if not all. Here's the standard form of a quadratic equation. ax squared plus bx plus c is equal to 0. And of course, the quadratic coefficient a should not be 0. If a is 0, then this will be 0, so the quadratic term will drop out. You have only a linear equation. So a should not be 0. And that's important because the quadratic formula has a in the denominator. So if a is 0, then nothing works. And by putting all those numbers into this quadratic formula, you're going to get any kind of quadratic equations done. It's not the most efficient way, and if there are some additional characters flying around, not just one character, x, but some further parameters flying around, then quadratic formula method is not very good. Still, if we have all numerical coefficient, then it works. And maybe it's a good idea to start with those examples. Okay, here's one. And then let me open quadratic formula here. Standard form is also reproduced here, so I don't need that. So let's talk about this. Alright, so x is, let's just copy and paste this. We have a fraction, so let's increase the font. And then okay, alright, here. And then copy and paste once more. Okay, in place of a, let's put in a value. A value is 1 in this case, right? Nothing is here, that means 1 is hidden. So here, in place of a, 1 is hidden. Now how about b? b is negative 6. Here we have plus b, and this is minus 6, so negative is hidden. So in place of b, and then in place of b here, and finally what is c? c is 4. So you need this computation. Not too bad. Negative 6, so that's positive. So that's positive 6. Oops. And down here, 2 times 1 is just 2. And negative square, so it's positive, so we have 36. And 4 times 1 times 4 is 16. Further simplification, okay, let's go ahead and further simplification. This is 20. Now, can you simplify this further? Can you simplify this further? Well, 20 is 4 times 5. And 4 is a square number, so it can come outside of the square root. But if it comes outside of the square root, we have to take square root of 4, so that's 2. And finally, we can remove the denominator. Divided by 6, so 6 divided by 2, so 3, and then plus or minus, and then divide away. So that's your solution. In other words, x is 3 plus square root of 5, or x is 3 minus square root of 5. You can always use quadratic formula in any circumstance. Keep calculator ready if you have some further computation to do. But if you can keep it as symbolic expression, this is perfect. And most of the time, this kind of answer is preferred. There are exceptions, of course. If you have something like this, then you have to type it out and get a digit string. everything here is given in terms of 3 decimal digits. See that? So after getting your solution, you have to round back to the 3 decimal digit. That's the usual thumb. That's usual rule of thumb for the theory of effective digit, error analysis, whatever you may want to call. Again, let's use quadratic formula. How do you use that? Okay, can I erase this? Yeah, okay. Solution is here, so I don't need this anymore. And as for this, well, let me just go ahead and show you. There's no way I can reproduce kind of computation with mental math, so better not start. Just plug in b here. This is negative and then double negative, so we have actually negative of negative here as a matter of fact. And then here, this one, negative of that thing squared. So we end up with actual positive of that thing squared. And then a value is 2.725, b is like that, c is like that. So, you know, it is just a matter of using calculators to do your computation. And then we have the square root computations and all. So we have this plus square root over that, 3.599 something. And the subtraction and divide by that, we have negative 0.427 something. And if you have decimal expression, then there is no other way. You have to use quadratic formula. And if this kind of problem comes from quadratic modeling, such as some geometry problem or some business problem where you have to set up appropriate price tag or whatever, in that case, it's quite likely this negative thingy is a fake solution, extraneous solution, or invalid solution. But at this moment, for this problem alone, nobody can tell. There must be some circumstance that it's quite clear that I have to choose the positive answer only, and you're going to see those kind of things in any kind of modeling problem. Anything associated with geometry is most typical, and for business, I'll be careful. Negative may mean something, it's just a loss, but in a lot of cases in modeling, only this will probably be the right answer. What did I do here? Oh, just mathematical computation, no big deal. Anyway, a surefire way to solve any quadratic equation is a quadratic formula method. And I did that before anything else because I wanted to make sure that everybody can do quadratic equation, every quadratic equation, including something complicated like this. As for the derivation of the quadratic formula, I'm not going to do that here in this course. And then as for intermediate step toward the quadratic equation, quadratic formula, it's coming from the square root method. X squared is, say, d, and x is plus or minus square root of d. And likewise, ax plus b complete square is d. Then ax plus b is plus or minus square root of d. And if you solve for x, then this is what you're going to get. Minus b plus or minus square root of d over a. And compare that with the quadratic formula. They look deceptively simple, don't they? Indeed, this quantity d is called the discriminant. And when discriminant is positive, inside of the square root is positive, so we have two real roots. When discriminant is 0, then inside of the square root is 0. That square root part is consequently 0. So we have a double root, negative b over 2a, because, you know, all this just drop out. That's just 0. And finally, inside of the square root is negative, then there's no real root. No real solution. Okay, we completed quadratic formula. That's against the normal order, but I think that was a bit more appropriate. After all, this is a review after going through all this many times already, so I think I can afford that. Alright, we just completed quadratic formula and related topic, and then square root method. Good. In the next video and next several videos, we're going to review the factorization method.